All right, to start this, this is section 5.2. Let's go ahead and do a couple warm-up problems to remind you how to do ratios and solve for ratios. So here we're going to set up a proportion. So these are our like sides. So I'm going to say 18 is to x as, so I want to match it now. If I did 18 first, I have to do 150 is to 75. Okay, and from here, we're going to cross multiply and cross multiply. So I'm going to say 150x equals 75 times 18. So 150x equals 1350. Divide by 150, divide by 150, I get x equals 9. Okay, go ahead and do 2 on your own. All right, there's several ways you could have set it up, but if you set it up right, you'll get the same answer. So I said x is to 3 as 115 is to 5. So I get 5x equals 3 times 115. Guys, remember all I did is cross multiplied. So when I did that, I get 5x equals 345. Divide by 5, divide by 5. X is 69. And remember, there's several ways you can set up this proportion, but you should come to the same answer every time if you set it up correctly. All right, so a congruent statement, guys. These are very, very important. A congruent statement basically states that two polygons are congruent. But it's more than just that. Order of the letters is important. The order of the letters, the order of the letters tells us everything. Okay, so corresponding parts of the polygon are written in the same order, and we'll do some examples here in a minute to where you'll see. A corresponding part is a pair of sides or angles that have the same relative position in two congruent figures. Okay, so let's look at this. If I wanted to write a congruent statement of this, I would say that triangle, and the order of the first one doesn't matter. The order of the second one just has to match the first one. So let's just call it JKL. Okay, well, if I look, my J has 2 arcs over it, so I always put 2 arcs over J. My K has 3 arcs over it, so I'm going to put 1, 2, 3 over K. And my L has 1 arc over it, so I'm going to put 1 arc over it. So triangle JKL is congruent too. Now, when I write the order of this triangle, it has to match this one. So like J has 2 arcs, my T has 2 arcs. Okay, K has 3 arcs, my S has 3 arcs, and my R has 1 arc, and so does my L, so I'm going to write R. So I know that the first letter here is congruent to the first letter here. So angle J is congruent to angle T. Angle K is congruent to angle S. Angle L is congruent to angle R, and so on and so forth. So when I'm asked for congruent angles, guys, after I get this, I don't even need this anymore. Okay? My congruent angles can come straight from here. So like first and first, I can say angle J is congruent to angle T. Second and second, angle K is congruent to angle S, and last, angle L is congruent to angle R. Okay? Now over here, congruent sides, it's the same thing, guys. My first two, JK. JK is congruent to first two here, TS. Okay? Last two, KL is congruent to SR. And then first and last, JL is congruent to first and last, TR. So here's all of my corresponding parts. All right, let's look at example 1. Okay, now we're giving a congruent statement, which is right here, which is very, very, very important to us. Okay, we can tell a lot by just these two. All right, so I want to find the value of x. So if I look here, I have an x here, but it's also paired with a y. So that doesn't do me any good if I don't have a y either. But I notice here I just have an x. Okay, so this term right here is referring to the length of this side of QR. Okay, so if I come back up to the congruent statement, my QR is the last two numbers, or last two letters, sorry, of this congruent statement on the right. So what I want to pair it with is the last two letters on the left. Okay, so from this I can get that FG is congruent to QR. Okay, well if I look down here, FG, guys, is 12. So I could say 12 is equal to, remember equal, if they're congruent, they're equal, is congruent to QR, which is 2x minus 4. And from here, it's just simple algebra, so add 4 to both sides. I get 16 equals 2x, divide by 2. My x here is 8. Okay, now I'm going to solve for y. Okay, well I have x and y in here, but I've already solved for x, so I can just go ahead and replace this with an 8, because I know my x is equal to 8. And this here, notice the degree symbol, that means it's referring to an angle measure. So this 6y plus 8 is referring to angle Q. So if I look up here, Q is the third letter listed on the right, so I want to pair it with the third letter listed on the left. So I could say that angle F is congruent to angle Q. Okay, now if I go and I look at angle F, oh look here, I know the measure of angle F, so I can say 68 is equal to, angle Q is 6y plus 8. And once again, now we just have simple algebra. So 60 equals 6y divided by 6. My y is 10. All right, so let's look at example 2 now. So it says you divide the wall into orange and blue sections along JK, which is right here. Will the sections of the wall be the same shape and same size? So right now, I have to show that if they're the same shape and same size, I have to show that every piece of this in orange is the same as every piece of this in blue. Okay, so let's just start. Well, I have AJ is congruent to, well, AJ just has one tick mark, so AJ is congruent to CK, so that's good. I know that AD has 3 arcs, it's congruent to BC, which also has 3 arcs, so it's congruent to BC. And then I know that DK has 2 marks, so DK is congruent to 2 marks up here, BJ. So the only side I don't know is JK of the left and JK of the right, but guys, remember this thing called the reflexive property of equality? I could say that JK is equal to itself, and so I know the all sides, or all corresponding sides, maybe I should say that all corresponding sides are congruent. All right, well, I need more for just the corresponding sides to be congruent. I have to show that all angles are congruent. Okay, so I know that angle A is a right angle and angle C is a right angle. So I can say angle A is congruent to angle C. Angle C. I know that angle D and angle B are both right angles. So I can say angle D is congruent to angle B. Now, let's think of this. If this wall and this line are parallel, right? And they are because they're both a 90-degree angle here. If I draw this as a transversal, top and bottom would be parallel as well. And if I draw this as a transversal, there we go. What do we know about angle 2 and angle 3? Angle 2 has to be congruent to angle 3 because they are alternate interior angles. And then likewise, can't I say that about 1 and 4 as well? Okay, so now I've shown that all 4 sides of the left are congruent to all 4 sides of the right, and I've shown that all 4 angles on the left are congruent to all 4 angles on the right. So yes, the figures would be congruent, and I could just say, I don't know, AJKD is congruent to A to J, so that would be C to K to J to be. All right, I want you to go ahead and try to do this one on your own, and then we will go over it. All right, so what you should have gotten is something that looks like this. Okay, now the first angles, B and D, G and E, and then H and F are all congruent. And then here, the first two letters, A, B is congruent to C, D. The next two, B, G, and D, E, and so on and so forth, to where you get all of these. Okay. Now, if I look down here, I want to find the value of x. So notice the value of x. It's listed as to help find the measure of angle H. Well, angle H is right here on the end, and I know angle H has to be congruent to F. Well, F over here is 105, so this is angle H, this is F. I set up an equation, do algebra, and I get x equals 25. All right, so here is a proof, and we want to prove that the triangles are congruent. So as of right now, in order to show that, we have to show that all sides of one is congruent to all sides of the other, and then all angles of one are congruent to angles of the other. So I can say that PS is congruent to QR. And then I could also say that ST is congruent to QT. And I can also say that PT is congruent to TR. And all of those are given. All right, so what I've shown now is that PS and QR are congruent, ST and TQ are congruent, and then PT and TR are congruent. So all sides of both of these match up to sides with the other ones. But that's not enough. I have to show that all angles are congruent as well. Okay, so notice I'm given something else. I'm given these two arrows. Okay, so hopefully by now you know that that means that two lines are parallel. So PS is parallel to QR. That's given. Okay, so if two lines are parallel and I have a transversal, what do I know about this angle and this angle? I know these two are alternate interior angles, and I know the alternate interior angles are congruent. Well, guys, that would be like saying angle S and angle Q. So I could say angle S is congruent to angle Q by the alternate interior angle theorem. Okay, and then likewise, if I have two lines here and I have a transversal that goes here, this angle and this angle would be congruent. Well, guys, that's just angle R and angle P. So I could say angle R is congruent to angle P by the same thing, alternate interior angle theorem. Okay, so I've shown two angles of one triangle are congruent to two angles of the other. Now all I'm missing is these in here. So what theorem do I have that tells me that this angle and this angle are congruent? I have the vertical angle congruence theorem to tell me that. Okay, so by the vertical angle congruence theorem, I know that angle PTS is congruent to angle QTR. Now be careful here, because you can't just say angle T is congruent to angle T, because these are two different angle T's. Remember, if there's more than one angle at a specific point, you have to use three letters. Okay, so now I've shown that all three sides are congruent. I've shown that all three angles are congruent. So I can say that the triangles are congruent. So the order of the first one does not matter. Let's just say PST. Okay, but the order of the second has to match the first. So what angle of this triangle corresponds to P? Angle R does, because P and R are congruent. So what angle corresponds to S? Angle Q does, because angle S and Q are congruent. And then last but not least, angle T over here corresponds to T over here. So I could say the triangles are congruent by the definition of congruent triangles. I know that's a lot, but it is doable. And luckily for you, we will learn ways that we don't have to do all of this.